Hello all, welcome back to System Design Interview series. Today's topic of discussion is Messaging Bridge. As part of today's session, we'll cover what is Messaging Bridge, what are the different issues and considerations to be undertaken when this particular pattern is being evaluated, what are the different scenarios when it can be used and when not to use, different existing solutions which can help us implement Messaging Bridge, and finally running it against the 5 pillars of system design. So Messaging Bridge pattern is used to connect two messaging systems or services that operate with different protocols or formats of data, enabling seamless communication between them. Let's look at the problem context. Many organizations and different workloads may unintentionally operate IT systems that rely on multiple messaging infrastructures, such as Microsoft Messaging Queue, MSMQ, RabbitMQ, Azure Service Bus, Kafka, Amazon SQS, and many more. This situation often arises from factors like mergers, acquisitions, or the integration of existing on-prem solutions and cloud-hosted components to improve cost efficiency and simplify maintenance. In simple terms, consider a legacy application which is built used around Kafka as the messaging infrastructure and another system which is built around RabbitMQ. For some solution to be built, both of these systems need to be integrated. There are two options. One, to rewrite one of the applications with a common infrastructure, or second option, to build a messaging bridge which helps seamless communication between the two different systems. Issues and considerations to be aware of: deduplication. If this integrated system involves distributed transactions where same messages can reappear or reoccur because of failure or any link challenges or any unknown reason. So this messaging bridge should be able to identify duplicate messages and should be able to handle the deduplication. One of the services involved doesn't run on a messaging pattern. Such systems would need an extra support to build a connector between their infrastructure used by the service and the messaging bridge. Single queue versus multiple pair queues. Single queue topology talks about involving a single dedicated queue for all service messages from one system to another system, where all the messages from system A lands onto one queue and all those messages are picked up by system B, and there is some kind of a tagging or indicator depending on which system B is able to identify which of the messages or type of the message coming in. The second one, multiple pair queues. In this particular topology, the suggestion is around having multiple shadow queues for each of the different service messages, and messaging bridge takes care of forwarding the messages between these queues. Competing consumers, again, as this particular system or the messaging bridge has to handle more of the load, there can be multiple competing consumers for the same messages. Now, the same message should not be processed by multiple consumers, or in some cases the same message might be required to be duplicated across multiple consumers. All these different scenarios of competing consumers needs to be handled. Retry and circuit breaker patterns. There will be an expectation from messaging bridge around at least once delivery, and in those cases sometimes due to different failure conditions, different unknown conditions, there can be a failure in message processing, and in that case retrial, as well as some downstream services can be down, and at that point of time implementing circuit breakers so that the upstream component or the services are aware of downstream service disruption, and when they are back and overall end-to-end services back, and to restore that connection. When to use this particular pattern? Integrating multiple existing systems with need for intercommunications. Integrating systems use diverse messaging services. And in cases like where we are extending a hybrid service, which is a combination of an on-prem plus cloud services, in those cases, many times service messaging are asynchronous in nature, and at that point of time, messaging bridge makes a lot of sense. When not to use, when system is very simple and can be easily modified to accommodate any messaging requirements, the change required to adopt the new messaging system is simple and it is not adding to the cost. Synchronous request servings are done. Most of the cases where we use messaging bridge, it's asynchronous messaging. It's not a very mandatory kind of a requirement, but generally security is a concern in cases like when the payload is carrying some sensitive data, and then this particular message a system would not like to pass it on over a shared service kind of a place, where messaging bridge might have to either uh, implement all the security or privacy challenges, concerns, address them, and then to use it, but it can add to the overall overload. There can be challenges around the volume or the message sizes also, where the messaging bridge or a particular messaging service might not be a right suitable candidate, and a valet key pattern may suit the particular solution better. Existing solutions: Apache Camel, Spring Cloud Stream, Confluent Kafka Connect, NatStream. Stream sets data collector. Mind you, this is a visual ETL tool which supports the bridging and uh, transforming data between RabbitMQ, Kafka, and other systems. So manual trigger mode on. Red Hat AMQ is another one, which is also known as ActiveMQ Artemis. uh, Recommendations many times is around when we are implementing a fresh a messaging bridge. If simplicity and the minimal resources are uh, the goals, then NATS is one of the ideal solution, or even a custom built solution messaging bridge in Node.js or Python script might be an excellent solution. Rounding it against a pillar of different pillars of evaluation, security does get in little bit impacted around when the uh, payload has some kind of a privacy or security concern. If not, then this risk is mitigated. Uh, Trade-off, another one is around cost optimization, because overall we are introducing a new infrastructure, new deployment pipelines, and then overall costs associated with the maintenance and support. So there's a cost angle which gets added out here. With that, I would like to end today's session. Hope you all liked it, and uh, hope to see you all soon on my subsequent session. Till then, happy learning and bye bye.